Okay, guys, very good evening. Thanks for joining the session. Let's kick off because this is little bit, I would say, too much of content is there in terms of explanation, but I have tried to keep it as simple as possible. But still, I won't like to go in a hurry burry. I would take time wherever you guys have doubt. Please ask your questions. Don't hesitate. It's everybody is a beginner. If somebody knows, well and good. If you don't know, that's also good. So you just have to ask your question. Don't keep it to yourself. I am here to explain. So let me just quickly share my screen. Okay. I hope my screen is visible. Great, thanks. So today, last time what we did was ANN, that is artificial neural network, which is the start or which is the uh, grounds for starting your neural network or any deep learning thing. That's where we start from. We ask that why ANN is required when we have logistic regression, when we have ensemble models, why this is required. So ANN works like a brain. It is fast processing. It takes the input, it learns from its own mistake, it goes back and corrects it. That's where the outcome that you get is more precise. The answers that you get is really good in terms of accuracy. But the problem with ANN is that it serves as a black box. Sometimes you don't have an answer how you are getting that output. So that becomes a challenge when you are working in an industry which requires you to have a white box models. But having said that, uh, now today we are going into CNN, that is convolutional neural network. Okay, so first, can anybody tell me which animal is this? Any idea? Okay, so let's proceed further. Now, okay, so you changed from mouse to cat. So, how you were able to identify this? With the eyes, right? Why? Because you have seen lot many cats, you have seen lot many pictures, right? Your brain is able to process that. First you were getting confused, okay, ears are there. Now your brain said, oh, these are the eyes, so this looks like a cat eyes. Your brain is trained on multiple inputs that it has got in the past, right? If somebody is not able to, let's say a kid, I'm giving, that kid has not been trained or is very new to these animals or these pictures. So might be I'm just showing these things, then I'm showing this picture. So brain is getting trained, and slowly that person or that kid would be able to identify that's a cat. That is what your CNN is going to do. CNN is getting trained on multiple images that you are going to give as the input. After training, it will, whenever you want to give any test image or any new image to identify which image it is, it will be able to do that classification. It's a cat, it's a dog, it's a bill, it's a ship, it's a car, whatever it is, but it has to be trained on that side. Now this cat is sitting, just the face is there. A cat could be lying, a cat could be dancing, a cat could be running, a cat could be on a tree, or whatever different pictures are there. You have to train your model extensively. But how the model learns? Any idea? This is no data, right? It is not a tabular data. These are not numbers, these are not text, these are just images. How your model will work? Any idea, guys? Okay, but my question is, yes, you will say that this is a cat, this is a dog, this is a bear, so on and so forth. But I'm asking, your model is taking the image. Generally, machine works on textual data, means not even textual data, on the numerical data, right? How would you get that? I'm not having that. Yep. Correct, based on pixels. So, why the need of this CNN? Pixels are there. It means I can generate the numbers. Use ANN na via new model. So let's say a small image of size 100 into 100 pixels is there with three colors, RGB colors, normal three colors are there. Okay. If I multiply this 100 into 100 with three colors, that means it is 30,000 inputs. In ANN, you would require millions of connections, which will make it very slow and computationally heavy. The other point is that ANN treats each and every pixel separately. It won't be able to say, okay, this part is the eyes because this area is, these pixels are working together and forming the eyes. It won't be able to detect the shapes, edges, patterns very clearly because it is working individually. So, what does CNN solves for you? It uses something known as filters to detect patterns like edges, what are the shapes, what are the different objects, and making it much faster and smarter for the image processing. That's why a new model for image processing. Are we good till now? Yes, no, any questions? Okay, great. So let's proceed further. And see, whenever we give any model to the any data to the model, what happens? It will do the training. It will do some back end maths and all these things. You are not doing the calculation with pen and paper, but always it is good to understand what is happening at the back end, and that's what we are going to learn today. So there are few concepts which are very important, which we need to know. One is known as filter, okay. Second is known as convolution. Third is known as the feature map. So filter is also known as kernels. Convolution is the operation that is happening on your image, or it is like a feature selection that is happening. And then the feature map, that is the output. After that, we apply the activation and other things and then get the output. That we will come to slowly, slowly. But first, let's get into your filters. So see over here. My pen will, okay. Anyways, I'll see. If you have given some input as a hand drawn one, okay. So what is this? I've just I did it on PPT, that's why it is like this. But if it is a hand drawn image of one from here till here, this is one, this is a, so your system has to identify that it is a hand drawn image of number one. Now all these grids that you are seeing, you don't have to bother about it. System already learns it on its own. But this is just for explanation that I have given it. Let's say wherever you can see the design of one, this slant line, this vertical line and horizontal line, I have given a number one. Wherever one is not, wherever the part of one is not there, that is just marked as -1, means that is not important, or it is just the white area or the gray area. We are not bothered about that. So this one has three patterns that your machine needs to identify. What is that pattern? First pattern is the slant line. Second pattern is this vertical line. And third pattern is this horizontal line. These three parts together make your one. And that is what your machine has to identify. But how, and that's what I have shown you. First, I showed you the ear. You said it's a mouse. So it was just one part. Then eyes, then nose, then whisker, and then we can combine and say that's the cat head. Or we can next have the legs, the hands and all those things, a tail, and then we can say this is the body, head and body combined. Is this a cat? Yes, it is a cat. That's how your model will give the output. But over here, we are just keeping it simple to understand how it works at the back end. So this is slant line, vertical line and horizontal line. Three pieces are to this. So first thing that we look into it is filter. Now what is a filter? Filter is this grid I have just shown you in the picture of one. Okay, so that is the same number. This part is known as filter. What is a filter? Filter is a small grid. Generally, we keep it to 3 by 3 or 5 by 5 or 2 by 2. These are the sizes generally we keep it. It is used to scan across the image and detect the patterns like the edges, corners, texture, colors, all those things. Since I know that I'm looking for a slant line, so what I did, I created a grid. This is just one filter that I have created just to identify the slant line. That is one of the pattern in number 1. So what is this? This two grids, I have marked 1, 1, rest all of them -1. So this is the pattern that I have to identify. Now, since this is 3 cross 3, I will take from here, from the starting, that is the bottom left corner, 3 cross 3 matrix. I will multiply -1 to -1, -1 to 1, 1 to 1, and like this, and then take an average. Because this total numbers are 9, it is coming -0.11. So -0.1, this goes over here. Now, why this grid size comes, you will understand in a while. Okay, so this is the first input. Now what I did, I will shift it further. It is known as the stride. That is the one shifting that it is done. This row is left, it is the stride is shifted to 1. You can keep the stride 2 also. Generally 1 or 2 strides are considered. If I will select 2 stride, then it will take this third row, third column, fourth column, and the fifth column. It will leave the first 2. But why to miss that? So that's why generally we keep stride as 1. You can try in your notebooks with the stride 2 also. It works. Same filter I have taken because I have still not completed my slant position over here. Okay, so all of this is going over here, multiplied, and then I got the number 0.55. Again stride 1, got it over here. Next time if I go, I will go this way. This block will come into picture. Similarly, you will keep, as you move on, you will see that your size of this matrix has been reduced to 3 cross 7, 3 cross 5. Okay, this would be the new size that you are having. It would be 5 cross 3, number of rows into number of columns. 5 cross 3 matrix would be formed. This is the feature map that we are understanding. Wherever you will have the pattern, that slant pattern it has identified, it would be either 1, that block would either be 1, or it would be near to 1. So let me just try to edit this one. Okay, so suppose you get a number over here, something I'm not calculating it, something I'm writing over here. Something like this complete thing would be filled up. Now, wherever I am getting the most positive number, if 1 is not there, most positive number, in this case, I got the 1, it means my slant is coming somewhere over here. I am able to identify this is there, or I am getting this number and this number. So let's say this was 1 and this is 0. So what is this? I am getting my slant line in these two blocks. Okay, it is coming somewhere over here, it is coming over here. So like this is forming my slant line. So I identified the pattern. Similarly, another filter would be there for vertical line. Another filter would be there for your horizontal line. Now what are these? What is happening with this? The filter will react strongly where there are changes from left to right in the pixel, means in the vertical edges. Wherever you have the changes, it will work on that and it will be able to identify whether that pattern is matching or not. The process of sliding the filter, I told you stride, the sliding that is happening across the image and computing the values, that is known as convolution, or that is the operation that is happening. Place the filter on the patch of the image, multiply the filter value with the corresponding image pixel that you have, this filter value on the image pixel value, add them all up, gives one number. move the filter to the next patch. So what is this? This is convolution. The operation is happening to identify the pattern, and this gives you the output, which is this output, this matrix. It is known as the feature map. So it is like you are taking a stencil and sliding it over the picture. At each spot, you check how much the pattern in the stencil matches the picture, right? So that's what we are doing over here as well. So this pixel is, the size of the image is getting zeroed down in terms of feature. It is uh, becoming compressed. We are able to identify, okay, this is the edge, this is the pattern, this is the sliding line, this is vertical, this is horizontal. Like that, it will identify for the cat also. It will be able to identify. Okay, so over here, this is the eyes. So it is multiplying with this filter. This is the eyes. Okay, over here, this is the nose. It has identified. These are the ears. It has identified. These are the ears. Just some rough image. And then it will have an other filter. It is not always that filter has to be 2D, it could be 3D also. So then it is multiplying these with the filters, aggregated one with the filter, and it will say, okay, this is the head. I'll get first output that this is the head. Next one, similarly, if I have the body, hands and legs together, body. Now, I got head, I got body, all combined together. Over here, it is coming as, we will flatten it to 1D array because I have to reduce the time. I understood the pattern and I reduce the time over, reduce the, uh, uh, what do you call, the size of the matrix, the pixel size, to just the pattern. Okay, this is the head, this is the body, combine it together, and now we will send it to dense neural network. What is dense neural network? Nothing but your ANN. So these are the steps which are extra that are happening in your CNN. So what we have? We have filter, we have the operation, that is convolution, we have the feature map that is working on top of it. Sorry, feature map that is being created finally with the help of this convolution. So like something like this. Oh, where this went? Yeah. So this cat, multiple, I'll come to Relu in a while. So multiple convolution happens to identify eyes, nose, ears, all whatever we are doing. Let's say this face identification happen, and then pooling I'll come to in a bit, and then we have head and body one also, and then again pooling. Now what is pooling? I've just shown you an example over here. Any idea what is pooling? Come on, guys, it is very simple. Eyes, nose, ears combined. What is pooling? That is your convolution. What is pooling? So pooling means I'm reducing always my size of the feature map. This is my feature map, this is my feature map, this is my feature map. Now I'm combining this to have another filter on top of that, that is head. I'm reducing this feature size just to one. These three are getting combined and my feature size is getting reduced. What will happen with this? First, I was having a very big matrix. Then I applied a filter on top of that. I was able to make it small matrix. Then further I combined it and I am able to get a one feature map of this head part, this body part. Then I am able to flattening it. What is this? I'm reducing the size of the feature map. I'm just keeping what is the most important information. This eyes, nose and ears are the most important. Rest of the background doesn't have any impact, right? So that's what I'm taking into account, and that is known as pooling. Now, pooling, there are three kinds of pooling: average pooling, max pooling, and min pooling. Most of the time, we use the average pooling. So, what is average pooling? When I was explaining this one over here, so what it will happen, which it will take 2 by 2 tile. Generally it takes, for max pooling we will take 2 cross 2 tile, and whichever the stride one only, whichever is the maximum. What is maximum over here? So if I say this minus 0 0.11, 0 0.551 and 0 is there, which is the maximum over here? 1 is maximum. It will take, okay, just 1. Then 0.55, 0.33, 0 and 0. So it is something like this. Is that, yeah. Let me draw it over here. Okay, so if I do max pooling for 2 cross 2, first I will take this one. Next block would be this one if I'm taking the stride of 2. So means I'm skipping this 2 and I'm going directly over here. This block and these blocks. Only 4 would be there. My output will look like now a matrix of 2 cross 2, which is maximum over here 8, which is maximum over here 9, which is maximum over here 5, and in this section it is 9. So this is again my feature map size has been reduced. It makes my computation faster. I'm just keeping the important information, because if you remember when we were calculating based on the filter and all, which wherever your pattern is matching, that number would be maximum. So I'm just keeping the maximum information or the most important information, and I'm leaving out rest of the information. Average pooling it is, instead of taking the average, I will take the instead of taking the max, I'll take the average. And similarly, you have min pooling, which we generally don't use. It is the max or the average. Max pooling generally gives you the strongest signal. Average pooling will give you the overall summary. So most of the time you will see that we use max pooling only. It tells you which is the most important part of that image, or which is the most important aspect that your training data is capturing from that image. Okay. Is this clear, guys? Are you able to understand what is pooling? Yes, no, any questions? No questions, all good? Okay, fine. So, where were we? Yeah, okay. So, convolution happens, but before pooling, one more thing comes into picture, that is ReLU. Anybody knows what is the full form of ReLU? Last time we have also talked about this in ANN. So ReLU is your activation function. The full form of this is rectified linear unit. It is to make your feature map uh, that you are generating after putting the filters, after all this convolution and all these things, to make this as your non-linear part. Why? It makes your network non-linear. Why? Because the images that you get is non-linear only. You don't have the linear images. So we are removing that aspect. And the computations becomes easy and fast when we apply ReLU. So that's the reason that we are applying ReLU on top of it. Okay, and what does ReLU do is, if suppose um, my matrix, my feature map is like this: -2, 3, -1, 0, -4, 5, 1, -6, 2. It will just keep the positive number, whichever are lesser than 0, it will convert it to 0. So it will become 0, 3, 0, 0, 0, 5, 1, 0, 2. This is what it will form. So it is making it non-linear in nature when we apply ReLU on top of a feature map. It is again helping in scanning the means it is making sure that you have the right signal, you are processing the data as non-linear, you just because of too much of mathematical calculation, we are not losing the impact. So ReLU will keep the positives and it will cut out the negatives. It helps your CNN focus on useful pattern and ignore the noises so that we don't have the overfitting in the model. We have other activation functions also, like we spoke about last time, sigmoid, TANH and all this thing, but ReLU is the one that is preferred in CNN. Are we good, guys? Any doubts, any confusion? Okay. Yeah. So this is what we have for CNN in terms of simple theory. Now if we get into the this collab notebook, then we will see how this model is built. It takes time for the training, so I have run this already. I'll show you, and some of and we'll talk about the hyperparameters also. But meanwhile, if you have any questions, then let me know. In just in terms of theory, I've kept it very simple. What is important to know for you, I've just conveyed that only, nothing else, nothing extra. Lot and lot is there. You can go behind the maths and all those things, but we are here to learn about Gen AI. That's why I'm focusing on only the important aspects which will help you in preparing for the basic knowledge of CNN as well as for the interviews when you are going for the Gen AI and understanding the concept. Guys, any questions, any doubts? Okay, what is the filter size? Can anybody tell me what is a filter, or and how generally what is the filter size that we keep? Yes, no, no one. I hope I'm audible. So what is the filter size generally we keep? We keep 3 cross 3 or 5 cross 5. These are the general filter size that we keep. So this is a small window that is used to detect the pattern. This is one of your important hyperparameter in CNN. You can play around with the filter size. Now comes number. I'll when I'll go through this, we'll see all these things. But still, I'm just giving you notes that what all things generally works as your this. See over here. Okay. So your filter size is there, your number of filters is there. It decides how many different patterns of CNN learns. More filters, it means more features. Okay, learns filters, this is edges patterns, how many filters you want over there. Okay, next is the stride, how many strides the filter moves when sliding. Stride 1, move 1 pixel at a time. Stride 2, skips the pixel. It is faster and smaller output is there. For with stride 1, you will have more details capture and bigger output, but it will take time also. It would be a bit slower compared to your stride 2. But we don't keep stride 3 or something like that. Either stride 1 or stride 2. These are the two options in your hyperparameter. Then another part comes into picture is pooling. So as I told you, we usually use max pooling of the size 2 cross 2, or you can use of the size 3 cross 3 also. But generally we take it as a 2D max pooling and we use it 2 cross 2 only. If you remember, in ANN, we had learning rate, we had the batch size, we have epochs, and yeah, all these things that you have in ANN, most of these things are there in CNN also, because later part your dense neural network comes into picture. That is nothing but your ANN only. What happens, I whatever calculation I just showed you, you are not going to do it with pen and paper when you are working. You don't need to worry about that. When you, that's the beauty of convolution neural network. You just give it, give all the training images, it will learn the pattern. More the data, better it is. It will understand those patterns and it will do all this, whatever input you have, whatever hyperparameter you have given, the size of the filters, number of filters, max pooling, activation, and all those things, whatever you have given, it will learn from, it will use that, it will learn from the images, and it will give you the output. It will, when it is not giving you the correct output, again that back propagation happens, it will assign the weights on its own, and again it will learn. So that epoch is still there as we learned in ANN. So things remain same, no changes, but you have a addition over here where you are bringing convolution and pooling concept into picture. Okay, I hope that clarifies. Okay, so what is uh, what is the benefit of convolution, or what is convolution? The connection sparsity reduces when you use convolution. Means connection sparsity as in how your images are formed. When we use convolution and pooling, it gives location and the feature detection. Parameter sharing is there, which is not there in ANN. ANN works just on one pixel. Relo will introduce non-linearity. It speeds up your training and faster. It is faster to compute. What does pooling does? Pooling will reduce the dimension and the computation. It reduces your overfitting by taking just the important or focusing on the important aspect. It makes the model tolerant towards the small distortion because we are removing the noise, and your overfitting will not happen. So convolution, value, and pooling, these are the three things which are important uh, in terms of your CNN. Now, there, I've showed you the image of number one. Now, number one could be slanting also. If I'm hand drawing it, somebody can put it that there's a slant line is not there, just a simple one could be there. So, we can have something like this. We can have one like this also, one like this also. Somebody is making it like this, somebody is making just like this, anything, right? Or somebody is making a sleeping one, rotation is there, somebody is writing it like this, anything. Similarly, it can happen with any image, a cat image also. You can have multiple image. So what you need, you need to have different variants of your same image in the sample that you are giving in your training data set. If you don't have such image, then you can use something known as data augmentation. Okay, I'm not going into what is data augmentation, but there is a technique which is known as augmentation, which generates, it is a method to generate new rotated scaled samples from the existing training samples for the better training of your CNN. Okay, are we good, guys? Yeah. Yep. Please tell me what's the question. Huh? Uh-huh. Yeah. Yeah. Neural network. Yes. No, 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 no. Please go ahead. Please go ahead. Hmm. Mm-hmm. 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 Yes. 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 Correct. Correct. Yes. Yes. Right. Right. It will process. No, no, it is not enhancing or doing anything. It is that for, okay, let's take a step back to machine learning. Forget about CNN for a while. If you want to, you have a use case where you want to detect whether the whether customer will default on bank loan or not, right? A simple classification use case, binary classification. What do? You train the model. Correct? You train on what? You train it on historical data. Now that historical data has multiple features, means that has happened in the past. I have data of the customer that is working as the feature, and I have labeled it whether that customer has defaulted or not. Correct? Yeah. So on that, your model gets trained. Why you are training the model? So that tomorrow you can give some input of anybody who is applying for the loan. You don't know that person is for the first time coming to your bank. That person is applying to the loan, and you don't know whether that person will default or not. Uh, uh, based on certain aspects, you will be able to say, okay, I will approve the loan or I will deny the loan based on the risk aspect, right? So what you will do, you will take all those inputs. I want the CIBIL score, I want your salary, I want your other EMIs, I want your credit card, and all details and blah, blah, blah. What are the input features? You will give to your model. Your model, which is trained on the past data, it will do the prediction for you, right? That's what your machine learn. Now what is CNN doing? We are going to train the model on different images. Tomorrow if I am giving any image to CNN, it will be able to classify based on its learning memory that it has learned from the trained data. It will classify whether that image is a cat, a dog, a human, a vehicle, what it is. Does it make sense? Huh. Right. Right. Mm-hmm. 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 Right. Mm-hmm. That's what I'm saying. That is I've just showed you the means what happens at the back end when model is working. We are not going to give this filter each time. We are not going to do is any striding. We will just give multiple images. If you see this notebook, I have not gone through this, but if you see this notebook, I have multiple images of a frog, truck, multiple kinds of truck, two cars, a horse, bird, ship, deer, all these things. All these images I'm giving to my model to train. I'm not going to do that pen and paper exercise which I showed you. I'm just giving the hyperparameters. My model gets trained, and then I give my test data. My test data, it will be able to identify based on whatever it has learned from that cat image. So I have the pixels of the cat, I have the classification that it's a cat in my training data. I have the pixels of ship, and I have the label that it's a ship. A second image of a cat, and again a label of a cat. So that is my training data. Over here, based on the training data, it has understand the pattern. Okay, this kind of eyes means that it is a cat. This kind of ear means it. So this is what is the testing I'm now giving. I've given an image which I have not given the classification of it, that whether it's a cat, it's a bird, it's a dog, whatever it is. Now my model, which has been trained on that data, it will be able to classify over here that image is of what. Where do we use it? We use it in X-rays, MRIs, CTs. You're detecting tumors or COVID-19 in chest scans. Many places, the CNN only was used. Your self-driving car, your Tesla, is based on this only. Your facial recognition, how your Google says, or your Facebook is tagging your friend, that is CNN. Your image recognition and classification, your Google Photos is clubbing all your friends' photo. Okay, this is XYZ friend, all photos coming together of that friend. How? This is because it is trained on that CNN of all the images of that, and wherever it is able to see that, it says, okay, this person is XYZ. And then sometimes it does the misclassification also, because it is a machine learning model only. It is not 100% accurate. Your security and surveillance in your airport and all these things, your Amazon and Myntra search by photo option that comes. What is this? All this is CNN. Okay? Yeah. Yes. Yes, yes. No, no, no. It's not cats and dogs. I'm just giving you the example of simple thing. Okay. So this is your models are trained on huge things, okay? And right now that trend is going on in Gemini, that you give people are giving their photos, it is making that 3D model, ladies are giving their photo with that sari and that flower in the hair. That trend is going on, right? We got the Ghibli trend in Chat GPT also. What is that? How your AI, how your Chat GPT or Gemini is able to generate the images? It is taking that data, it is getting trained on that, and it is giving you the output. So to learn that how that generative AI is generating those images, we need to know CNN. Okay? Okay. Okay. Yeah. Any other questions? Okay. Fine. So let's go through this notebook. Pretty much simple and self explanatory notebook as usual. As the last time, also, I have placed the comments which are very straightforward to understand. When we are working on any model, the first thing is we need to import the libraries. We are importing NumPy, Matplotlib, and over here comes your TensorFlow or the Keras. It is used to build your CNN model. Matplotlib, NumPy, you know. So from your TensorFlow and Keras, I'm just taking the available data set, layers and models. This is what we have. The version of TensorFlow that is available in Google Colab is 2.19. Second is I'm not giving any data set from my local machine or something like that. I'm taking the available data set in these packages only. So one of the data set is known as Cypher 10. Okay, so that data set I'm taking, which has these images. Okay, this two images, two different kind of trucks. You can see this as blur images just for the faster processing and the compute thing. I have reduced the pixel size, I have normalized the pixel size, and thus I'm getting what are the different class names: airplane, car, bird, these all things. This is just to show you what I am getting over here. Okay, now let's build the CNN model. So what we have to do, convolutional 2D, that is your filter, learns the filter. Okay, max pooling 2D, it is used for that pooling thing, reducing your feature map thing. You can see it is 2 cross 2. Your filter size is 3 cross 3. How many filters are there? 32 filters. What is the activation? This is ReLU. What is the size of your input image? It is 32 cross 32 pixel image, and it is on RGB. That's why color is given as 3. When you have a grayscale, this would change over there. Okay. Now that is first layer I have created. Now second convolution layer I have created with 64 filters, size as 3 cross 3, activation ReLU. Input I don't need to give because input is going once only. Next time when I am having, it is the feature map of the first layer, first convolution layer. Max pooling over here also I have given 2 cross 2. If I don't give the stride size, it will automatically take as 1 only. Layers dot flatten, at the end I have showed you that it will flatten to 1D array so that I can give it to dense neural network, which is this part. I am giving the first size of the hidden layers 64, activation function ReLU. It is nothing but your ANN. In second hidden layer, 10 neurons, activation function softmax, and then I'm finally getting the output. So this is just whatever are the layers, it is giving you this, and how many parameters it has calculated with all these combination, that's what it is showing you over here. Once the model is trained, it learns on that. I'm using optimizer Adam. Now why optimizer is given, last time we went through that. It will update the weights. Why it need to update the weights? It is learning from its own mistake, forward feed and then going back to the backward propagation. So it will update the weights each time to reduce your loss as much as possible. Loss function, how we measure the mistakes. I'm using sparse categorical cross entropy. You can check over here what are the different versions and play around with that. Matrix I'm considering is the accuracy. You can have other matrix also. You can have F1 score, precision recall, whatever is there. You can use that. Over here I'm using accuracy. Now your model is done, model is compiled. Let's now train it. I'm training it on X train, Y train. Epochs 5 means 5 times maximum it will do forward feed and the backward propagation. That is also too much. It took around, I think so, 20 minutes or so for me to run this thing. So it will take time. That's why I've just kept as minimal as 5. You can increase it. Your model can run for 3 to 4 hours also. You will get a better model, but it's just that it is only for the simple data set, and for this session, that's why I've kept it as small as possible. My validation data is the test data on which I want to check how much is the accuracy. You can see the accuracy. First epoch is it was 57, second it increased to 62, third one went to 66, fourth one went to 67.15. The difference between the previous epoch and the next epoch is reducing. And the next one is 67.86, further reduced over here. I've given only 5 epochs, that's why it is just showing for this. If you will increase the epochs, it might improve further also, but I don't think so there would be significant improvement because this distance is almost coming to negligible. We evaluate it on the test data. We measure the accuracy since we took 5 epochs one. That is 67%, 60, approximately 68% is the accuracy, which is good. It's not a bad accuracy on this kind of data, and very small training, very simple model. Let's see how correct is your model. So what it will do is that accuracy, how correct the model is over time, loss, how much error your model made while learning. This helps us if the model is improving, underfitting, or it is overfitting. So if you see over here, with each epoch it is showing, this is on the validation. After some time it almost became flat. After around 2 epochs it almost became flat, though my accuracy on my trained data was continuously increasing. Over here if you see, loss function again, on validation it almost went flat after 2 epochs. So on your validation set, after second epoch it is not making much of improvement, though on your training data set it has been reducing, but very slight reduction. So this means that you are not overtraining, overfitting your model. After this the predictions are done. This predictions are again to see this images only, and wherever it has predicted is it correct, it will give blue. If not, then red. So if you see, it has predicted cat, ship, and airplane, frog, and this as the correct one, whereas this car and the bird, it has predicted wrong. The prediction was cat, the true is car. Prediction was bird, and the true is frog. Over rest of them, it has predicted correctly. So quite good. It has done wonderful job. I'll show you one more. See this one. I just checked. That was on the testing data. I did the prediction. I did the prediction on the training data also, and all the images on which it was trained, it has been able to predict it correctly. Okay, so on training data, it is working well. On testing data, almost as good as your train. Just 2 images it was not able to identify. For your learning, you can change, you can increase the epoch to 5, from 5 to 10 and 15. You can add one more convolution network and the pooling layer. You can use dropout. Again, dropout is one of the one of the hyperparameter which is used to avoid overfitting. Try to add that also, and try to use this data set, MINS data set. It is on the gray scale. It is not a colorful one, or you can continue to use this only. You can change your ReLU to TANH or sigmoid and try with that also if it works. It will not work well, but still you can give it a shot and learn from it that how, what is the problem that it is causing, or how it is not able to give you such a good prediction which ReLU was able to do. So this is what is CNN, a very simple notebook, and as simple uh, as simple explanation as possible I've kept it. If you have any questions, then please let me know. Yeah, yeah, then. Hmm? This data set is the it contains the images. That's what. See, I told you I'm training on the images, and these are the images that I took from that data set. What is the name of that data set? Cipher 10. Okay. This is the data set which is there in your TensorFlow library itself. From tensorflow.keras.datasets, import this. In CNN, you will do images only. Okay, CNN is for images. So you have to give images only as the input. What what is overfitting? In general sense, what is overfitting in machine learning? It is capturing noises from which data? From your training data, right? It means that it is able to do a prediction very well on the training data. Whatever example that I gave you before, that lone default one only. Let's say on training data, it is giving you accuracy of 100%, whereas when you are going with the test data, it is giving you accuracy of 60%. Means it has overfitted, it has overlearned, it is able to identify a small pattern in your data, but that is for the training data. In testing data which is unseen, your patterns are different. It is not able to capture that because it is looking only for that specific pattern which has it has learned. So that is overfitting. Okay, so we always try to keep the model as robust as possible. Robust means, hmm, yeah, give multiple images. You have 10 to 15 images. Just go ahead and give it and have an input. Yes, it will work. It has to work. Okay, it's just that, yeah, I'll share the. Just make sure that you know what is the pixel size. It since if you are giving the colored image, this three would remain. Just know what is your pixel size, the input shape that you are having. You tell me, just guess it. What is 32, 32? What could it be? Yes, 32 is the height, and next 32 is the width, and C is the channels, that is the colors. 3 stands for RGB, red, green, blue, which is for the colorful image. If you are having a grayscale image that is black and white, you have to give 1 over there. So 764 as in? Oh, high definitions, it's not that this model can't handle, it's that your compute would be able to handle or not. The Tesla works on this CNN only, right? You can understand their compute, right? How big it would be their compute. They are having the vehicle, that is the automated car, the self driven cars that is there. How it is able to identify, okay, this is a person, this is a rock, whatever it is. So that's just depends on your compute. It's not about the model. You require GPU, you require multiple training, you require a larger data set, you require time and everything. Okay. So if you are asking that it can handle HD images or not, yes, your CNN can handle HD images, 1280 cross 720, 1920 cross 1080. All these things it will be able to handle. It's not that it won't be able to handle, but what happens? See, I told you this 32 cross 32. If you multiply and multiply with 3, the values that you will get is 3072. Okay, 3072 values. Computation would be faster. Means these many params, these many neurons and all these would be working. Whereas if you have a HD image which is 1920 cross 1080 cross 3, it means you will require 6.2 million values. You need lot more memory, GPU power, as well as time. It is a very, very heavy model. Okay. Yeah, just why I'm telling you this is, first get your hands dirty only to understand this code is running, play around with multiple parameters, working on a larger data set is after when you learn about this basics. If you don't know the basic, you won't be able to get over there, right? Mm-hmm. Yeah. Hmm. Mm-hmm. Uh-huh. 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 No, 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 no. That is not something that we are doing over here. It's not this level of CNN won't do. Yes, if you remember, and now also in offices somewhere at least you would have seen, they have put that detection that during the COVID time, when you go past the gate, that green images comes if you are not positive, right? It was detecting the temperature, right? And the red image used to come when your temperature is there, you are high, so the alert would be there that this person is having a temperature, but it is not showing the names of the people, right? It can't show that. So that is not there. CNN is for the image detection. It is not for telling the names or the location or something like that. But yes, there are models built on top of it further which can identify, like your Digiyatra. In Digiyatra, you give the face, but along with that, you give the name and all those things. So there is one part CNN, but there are other aspects also to that which are matching your profile to this. Mm-hmm. 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 Uh-huh. Mm-hmm. Mm-hmm. Right. Yes, it is based on CNN only. If you see what I have given the labels to this. This is the frog. Now, let's say instead of this frog, I give the name Nitali. Instead of this truck, I give the name Arun. I'm giving the classification, right? So what is that? So it totally depends on your training data. If you have image of whatever with that camera, you have clicked the pictures, that pictures you are giving to the models later on, you have to label those pictures first. You have to do that annotation. Okay, this picture is of a stone, this picture is of a neem tree, this picture is of this kind of a horse, whatever, but you have to label that, and then only you can give it to the train data, to your model to train it. Okay. No, clustering is not related to this. Clustering is unsupervised, this is supervised. Yes, it is doing the prediction over here, right? It is when you are giving the test images, it is doing the prediction that it is a cat or it is a horse, whatever it is. It is giving you the prediction, right? Mm-hmm. It's not clustering. Again, if you are giving multiple images of a kid, of a old person, of male, female, whatever, you can label all that as human. If you are giving different building pictures, you can label all of them as building. So it is not about clustering, it is just what is the label that is present. Okay, so CNN is supervised and clustering is unsupervised. They are totally means you can't combine it together. Okay, yeah. Okay, guys, any more questions? Okay, I'll share the recording as well as the link for the Google Collab. And in next session, probably we would be focusing on RNN and LSTM. But if you have any other topic in mind in deep learning related to ANN or CNN only, which you want further explanation, please let me know in the WhatsApp group itself. Okay, thank you guys.